When you think about your smartphone, your laptop, your car, pretty much everything we rely on today, what do they all have in common? Well, it turns out they all depend on one single incredibly tiny invention that completely changed the course of history. That's a pretty bold statement, right? But you know what? It's not an exaggeration, not even a little bit. So today, let's dive into the amazing story of the transistor, the microscopic switch that literally built our digital world from the ground up.
So, where does a story like this even begin? You might think Silicon Valley, but nope. We've got to go back, way back, to a legendary place on the East Coast, the one and only Bell Labs. All right, picture this. The year is 1947. The world is still putting itself back together after World War II. And inside Bell Labs, three physicists, John Bardeen, Walter Brattain, and William Shockley, were tinkering with something that was about to, well, redefine everything.
And get this, look at what they made. This wasn't some sleek, futuristic-looking device. I mean, it's literally a chunk of germanium, some gold foil, and a paperclip. It honestly looks more like something you'd build for a high school science fair, not the invention that would kickstart the entire digital revolution. Kind of wild, right?
But don't let its looks fool you. This clunky little thing was on the verge of doing something absolutely revolutionary. See, for the first time ever, they were about to use a solid-state component. That just means no moving parts, no glowing hot vacuum tubes like in the old days, to amplify a signal. This was it, the moment of truth.
Can you just imagine the tension in that room? All these brilliant scientists, years of work, all coming down to this one moment. They hook up a microphone to their little contraption and a headset on the other side. Walter Brattain leans in, takes a breath, and says something into the mic. And bam, his voice comes blasting through the headset 100 times louder. It worked. It actually worked. I mean, this was a massive moment of triumph. History was made right there. For the very first time, a solid-state device amplified a signal. The transistor was real.
Okay, so how on earth does this thing work its magic? It sounds super complicated, I know, but you really don't need a PhD in physics to get the basic idea. All you need to do is think about something you use every single day, a water faucet.
Okay, don't get scared off by all the symbols here. Just focus on the faucet. It's actually a perfect analogy. Think about it. With a faucet, a tiny little twist of the handle controls a great big flow of water, right? Well, a transistor does the exact same thing, just with electricity. A tiny electrical signal is the handle, and it controls a much, much bigger flow of electrical current. That's it. That's the core concept. But of course, technology never stands still. Just like you can have different kinds of faucets, knobs, levers, this simple idea started to branch out. The transistor family split into two main competing designs. And believe it or not, the battle between these two designs would decide the future of pretty much everything.
All right, let's meet our first contender. This is the original, the OG, the direct descendant of that first paperclip and gold foil invention. It's called the bipolar junction transistor, or BJT for short. Here's the key thing to know about the BJT. It's a current-controlled device. What does that mean? Well, going back to our faucet, it's like you have to let a little bit of water flow through the handle itself just to turn it on. You have to spend a little current to control the big flow of current. Got it?
And for a long time, the BJT was the king. It was the workhorse of the electronics world, way better than the huge, hot, power-sucking vacuum tubes it replaced. And that bipolar name, it just means it uses two types of electrical charge to do its job. The familiar negative electrons and their weird positive charge partners, called holes.
But while the BJT was ruling the roost, a new challenger was waiting in the wings. And this was the real game changer. Let's meet the transistor that would go on to conquer the world, the MOSFET.
And here is the absolute game-changing difference. The MOSFET is voltage-controlled. Remember how the BJT needed a little current to turn on? The MOSFET doesn't. You just have to apply a voltage. It's like having one of those fancy touch-sensitive faucets. You don't push or turn anything, you just touch it. It takes almost no energy at all to switch it on.
So you've got these two different ways of turning the faucet on, using current or using voltage. And this one single difference set up a huge technological battle. Seriously, the winner of this fight would go on to define the future of basically every gadget you will ever own.
So let's really break it down. The BJT needs a constant little trickle of current to stay on. Think of it like holding down a button. The MOSFET? Nope. It just needs a quick touch of voltage, like flipping a light switch. You flick it on, and it stays on, without any more effort. That sounds like a tiny detail, right? But the consequences, oh, they are absolutely massive.
And when you put them side by side on paper, it becomes super clear why one of them won. Look at the MOSFET. Power consumption, super low, especially when it's not actively switching. That whole input impedance thing is just a fancy way of saying it's incredibly easy to turn on. It's fast, it's efficient, and while the BJT is still a champ for certain things like audio amplifiers, the MOSFET was practically designed for the digital world of ones and zeros. And that's why the MOSFET took over. It all boils down to that incredible efficiency and super low power draw. Because they use so little power, they don't get very hot. And because they don't get hot, you can shrink them down to microscopic sizes and cram, well, not just thousands or millions, but now billions of them onto a single tiny slice of silicon. And that, my friends, is an integrated circuit, the brain of every modern device.
So if there's one thing you take away from all this, it's this. Without the MOSFET's elegant, super efficient design, none of this would be possible. No powerful computers, no smartphones, no internet as we know it. The very device you're using to watch this right now, it's powered by billions, literally billions of these tiny little voltage-controlled switches.
So there you have it. We went from a funky-looking contraption made with a paper clip to billions of switches, smaller than a virus, that run our entire world. It's an incredible story. And it really makes you wonder, doesn't it? What little invention is being pieced together in some lab right now that's going to completely reshape our future?